Jai Hind everyone. Today I am going to discuss the feedback characteristics of the control system. As you know that the feedback characteristics, the feedback of the control system not only improve the error of the system, but it also improve the sensitivity of the system to internal or external disturbances, to parameter variation. So that's why I have chosen this topic. And the content for today's lecture are: what will be the effect of parameter variation in open loop system as well as in the closed loop system? Then what is the effect of sensitivity of a control system for both open loop and closed loop system? And if time permits, I will discuss the effect of feedback on the time constant of the control system. So starting with the effect of parameter variation in closed loop in open loop control system, let us consider this transfer function GS. As you know that the block diagram for the open loop control system is this, where this parameter GS is the gain of the system and RS is the input to the system and CS is the output to the system, right? So if we see here, the output of the system can be written as CS will be equals to, or transfer function of the system can be written as CS upon RS will be equals to the gain of the forward path, that is GS. I'm talking about the open loop system. I have drawn the block diagram as well. This is the block diagram of open loop system, open loop, closed loop, open loop control system. Okay. So the transfer function of the open loop control system is GS, and if I want the output, then the output will be RS into GS. Let's say there is a change in the variable in the parameter GS by delta GS. Okay, let there be change in gain, small, very small change in gain, that is, let's say delta GS. Then obviously there will be change in the output as well. So the the change in output will be delta C. So shall I write this CS plus delta CS, that is change in the output, will be equals to RS into GS plus delta GS, right? Now if I am opening this, then it is coming out RS into GS plus RS into delta GS. Okay, as we know that this CS into RS into GS from equation will be equal to CS, right? So if we compare the left hand side and the right hand side of this equation, then we'll get the delta CS, that is change in output due to the parameter variation in the forward path, will be of the open loop system will be RS into delta GS. Okay, let us consider this equation as equation number first. Okay, now for closed loop system. For closed loop system, there is small variation in the parameter forward path in the parameter GS, that is forward path gain. First of all, I will draw the block diagram for the open closed loop control system. This is HS, which is a feedback, and GS is the forward path gain, HS is the feedback path gain, CS is the output here, RS is the input here, and I am taking the negative feedback. Okay, and the error is coming out from the summation. Okay, now for closed loop system, the ratio of the transfer function will be Cs upon Rs can be written as Gs upon 1 plus GSHS. Okay, for negative feedback, this is the value of the transfer function. Now let's say there is again a small variation in the parameter Gs. So that is given by delta G. Okay, let there be small variation in Gs be delta Gs. Then again we'll get the new output. There will be variation in the output as well. From here I can get the output. Cs will be equals to Rs into Gs upon 1 plus GSHS. Okay? So the new output will be Cs plus delta Cs, and the value will be Rs will remain same and Gs will be plus delta Gs will be changed by the amount Gs plus delta Gs upon the 1 plus. So splitting these term, I am getting Rs into Gs plus Rs into delta Gs upon 1 plus GSHS plus delta Gs into Hs. So here this term is very small as compared to these terms, this term. Okay, so I can neglect this quantity. So neglecting this term as it is very small, I'll get only this term. I am left with only this term. Now I'm splitting the numerator. I can write it as Rs Gs upon 1 plus GSHS and plus Rs into delta Gs will be equals to, upon 1 plus GSHS, right? And this will be equals to Cs plus delta Cs. As we know that this term, you can see from this equation, from equation here, I can write this term as equal to Cs. So if we compare the left hand side and right hand side, we'll get the value of delta Cs will be equal to this, right? So I can write delta Cs will be equals to Rs into delta Gs upon 1 plus GSHS. So this is the change in output due to the variation in the forward path of closed loop system. So if you compare this equation number 2 with this equation number 1, which is for the open loop control system. So you can see there is the output of the closed loop control system will be reduced by the factor 1 plus GSHS. Okay, right? So this is the parameter variation I have. Now coming to the sensitivity of the control system. Okay, now sensitivity of a control system can be defined as percentage. Let's say there is a let me start it once again. Let there be a parameter let there be a variable t which is varying due to change in parameter k of control system. Okay. So the sensitivity can be expressed as STK will be equals to percentage change in parameter T with respect to percentage change in parameter K of T upon delta of ln of K. Okay. So it can be written as, so the sensitivity you can write this as 1 upon T del T, and this term can be written as 1 upon K of del K. Okay, so I can also write sensitivity of T with respect to K will be delta T by T upon, for solving the sensitivity of any control system, right? But you have to see which parameter is varying and which parameter due to change in which parameter. Okay, so here the parameter variable T is varying due to change in the parameter K. Okay, now talking for the open loop control system. For open loop control system, so we know that the value of the transfer function here is Cs upon Rs is equals to Gs. Now let's say I have to find out of the sensitivity of transfer function due to change in the parameter G, that is forward path gain. Then I can write it as delta T by T upon delta G upon G, or also I can write it as G upon T into delta T by delta G. Okay, so from this equation number, let's say 1, delta T by delta G will be equals to, since T is equals to Gs only, delta T by delta G will be equals to unity 1. Okay, so this term is equals to 1. So STG can be written as G upon TS is equals to again G here. Okay, so this is cancelling out, and the sensitivity of the transfer function of open loop system with respect to the forward path gain is unity. Okay. If we talk about the closed loop control system, okay, then the sensitivity of transfer function with respect to the forward path gain K will be equals to G upon T into delta T by delta G. Here the value of the transfer function for closed loop control system is 1 upon Gs upon 1 plus GSHS, right? So first of all I have to find out this term, delta T by delta G. So I have to differentiate this term. So this term will be 1 plus GSHS will remain as it is, and differentiation of GS will be equals to 1, then minus, and now numerator will remain as it is, and differentiation of this will come out to be only HS. Okay, and upon whole square of the term 1 plus GSHS का whole square. Okay, so it is coming out to be, this term is gets cancelled, so delta T with respect to delta G is coming out to be 1 upon 1 plus GSHS का whole square. Okay, now I can put this value in this equation. So STG will be equals to G upon T here. So I can put the value of T from this equation as well. So G upon, again, G can be written as GS upon GS 1 plus GSHS. ओके इनटू ये क्या आया हमारा सॉल्व करके डेल्टा टी बाई डेल्टा जी की वैल्यू आई 1/1 प्लस GSHS का होल स्क्वायर। ओके इनको सॉल्व किया जाए तो दिस गेट्स कैंसिल विद दिस टर्म and this term is also cancelled with this, and I am getting STG will be equals to only 1/1 plus GSHS. Variation in parameter G. Now, if we find out the sensitivity of the transfer function of the closed loop control system when the parameter with respect to parameter H. Okay. Sensitivity for closed loop system. Okay. Here I can write STH. Sensitivity with respect to the feedback. And here I know the value of transfer function will be I am taking negative feedback, so it is 1 upon GS upon 1 plus GSHS. Okay. Now I have to differentiate this TS with respect to HS. Now to delta TS with respect to delta HS will be equals to, so denominator will remain as it is here and numerator GS will come out to be 0 minus numerator remains as it is and the differentiation with respect to HS will give again the GS upon 1 plus GSHS का whole square. Okay, so this term gets 0, GS का whole square आ गया upon ये. This value को I have to put here, okay, and also I'll put the value of transfer function. So STH will be equals to H upon HS upon GS upon 1 plus GSHS. ओके और यहाँ से हमारे पास क्या आया इंटू माइनस ऑफ GS का होल स्क्वायर अपॉन 1 प्लस GSHS का होल स्क्वायर. ओके तो ये होल स्क्वायर तो विल गेट कैंसिल विद दिस टर्म और यहाँ से ये यहाँ आएंगे तो एक GS यहाँ से भी कैंसिल हो जाएगा. ओके तो यहाँ से I'll get the value of STH. I'll get the value of STH. Okay, from here I'll get the value of STH will be equals to minus GSHS upon 1 plus GSHS. So you can see that closed loop control system is more sensitive with the parameter H as compared to the variation in the parameter G. So I have in today's lecture I have discussed about the sensitivity of the open loop control system and sensitivity of the closed loop system with respect to G as well as with respect to H. Okay, and if we see that the sensitivity of open loop control system with the parameter G is 1, right, while the sensitivity will decreased by the factor 1 plus GSHS when it is compared with the closed loop control system, right? And if I am taking sensitivity, comparison of sensitivity of closed loop control system with respect to the parameter G, forward path gain G, and with respect to the feedback path gain H, then you can see that in this case we'll get the sensitivity minus GSHS upon 1 plus GSHS, and in this case I am just getting the sensitivity 1 upon 1 plus GSHS. So this is all about today's lecture. Thank you.